Good morning. In this session we will learn about AC generator. So we will see what is an AC generator, what is its working principle, and also we will learn about the construction of AC generator. Now you must be knowing what is a generator. A generator is a machine or a device which is used to get electrical energy. So we can see AC generator is a device which converts mechanical energy into electrical energy. Now the basic principle of this generator is the electromagnetic induction. You know what is electromagnetic induction, because in the previous 4-5 sessions we learnt about electromagnetic induction, and there I said, like in AC generator, in transformer, we use the principle of electromagnetic induction. Now we will see, using electromagnetic induction, how we can convert mechanical energy into electrical energy. So first we will see the construction of AC generator, or we will see what are the parts required in AC generator. You can think, by knowing the principle electromagnetic induction, what all you may need to convert mechanical energy into electrical energy. Like for example, the electromagnetic induction principle says that electromagnetic induction so in electromagnetic induction, an EMF gets induced. EMF is induced due to change in flux linking the coil. Flux linking the coil. Therefore, you can consider what all we need. We need a coil and we need a flux. Now, in AC generator, the change in flux is obtained by rotating the coil. Rotating the coil. So basically, AC generator consists of a coil which can be rotated in the magnetic field. Now, any AC generator, if you take, it will have a coil. So see this picture, it has a rectangular coil, and this coil is made to rotate in the presence of a magnetic field, or it is rotated in the magnetic field. The magnetic field are produced here using poles, and those poles are generally called, you can call them as field magnets. So field magnets are used to produce the magnetic field. And this coil is also called as armature coil. The coil is also called as armature coil. And the magnets, you can call them as field magnets. Field magnets are used to produce the magnetic field. Therefore, basically we can say an AC generator consists of a rectangular coil mounted on a rotor shaft. This is why rotor shaft, because it is mounted on a shaft and it is rotated in the magnetic field, and by rotating the magnetic field only you are changing the flux linking the coil. It is rotated at a constant frequency in a uniform magnetic field B, and from where this field comes, it is produced by external means. We use field magnets. The axis of the rotation of the coil is perpendicular to the direction of magnetic field, as shown here. This is the axis of rotation of the coil. So in this I have shown an anti-clockwise direction of rotation of coil. You can use clockwise direction also, as shown in the next figure. Now what are the uses of these listings and carbon brushes? Now when the coil is rotated in the magnetic field, an EMF gets induced in the coil. So if this coil is connected to an external circuit, a current starts flowing through the circuit. Now this is alternating EMF, so this can be connected to an external circuit. So you can make an external connection here and a current will start flowing. Therefore, the slip rings and carbon brushes are used to connect the coil to the external circuit. I'll erase this external circuit because for the generator we don't need it for the time being. The slip rings and carbon brushes are used to make an external connection. I have written that also here. Because of the rotation of the coil, the flux through it changes and hence an EMF gets induced in the coil. The coil is connected to an external circuit through slip rings and brushes. So very simple. Now you can recall, or I'll repeat, an AC generator consists of a rectangular coil which is also called as armature coil. The coil is placed in a magnetic field. From where does this magnetic field comes? The magnetic field is produced using field magnets or by external means. Now the coil is mounted on a rotor shaft. The coil is rotated in the magnetic field, and this rotation of the coil, because of this rotation of the coil, the flux linking the coil changes and EMF gets induced. The coil is connected to the external circuit using slip rings and carbon brushes. Now this is about the parts of an AC generator. Now we will see how you can produce the alternating EMF, or the EMF produced is sinusoidal in nature, or it is a sinusoidally varying EMF. The EMF induced will be according to the sine function, sine omega t. So we will see how you can produce an alternating EMF or sinusoidally varying EMF. Next you can write theory part, principle. So now we will consider a coil which is free to rotate in a uniform magnetic field B. Just let me say I have a coil over here. You can mark a rectangular coil also, and the coil is rotated like this in the presence of an external magnetic field. Let me say the magnetic field is in this direction. The coil is rotated in a uniform magnetic field B. So B is the uniform magnetic field. Uniform magnetic field. Now if the coil is rotated from this position, what is the area vector of this coil? This is A. Now A and B are parallel to each other. That is flux. The flux is given by BA cos theta. BA cos theta. Theta is the angle between B and A. Or if the coil is rotated with an angular velocity omega, that at any instant t, the flux will be given by BA cos omega t. You can also write, let me say, now you can say in this case theta is 0, so initial flux is maximum. The coil is rotated with an angular frequency omega Now here I have shown that the coil is rotated with an angular frequency omega. So at any instant t, the flux is then at any instant t the flux is given by phi, you know, equal to BA cos theta or BA cos omega t. Now that was the initial position. At any other position it will be like something like this, B, and area vector will be like this. So this is angle theta. So phi is BA cos theta, which is BA cos omega t. Now as the coil is rotated, the angle between the magnetic field and the area vector will keep on changing. The field is constant here, we are not changing the field as such. The flux linking the coil changes only because the coil is rotated. The coil is rotated and thereby the flux linking the coil changes. That is why the as I said in the beginning, the axis of the rotation is perpendicular to the magnetic field. Now in this picture also it is clear. See, in this case, this is in the initial position where we have assumed that the plane of the coil is perpendicular to the magnetic field, or area vector and B are as shown in this figure. You know, I'll show you here. Area vector and, you know, B and A are as shown in the figure, parallel to each other. Now if the flux is BA cos omega t, we will find out what is the induced EMF as the coil rotates. Then I'll explain this, how you can get sinusoidally varying EMF. So we know the flux is BA cos omega t. Now as the coil rotates, the flux linked with the coil changes and hence an EMF gets induced. You can write that sentence: as the coil rotates, the flux linking the coil changes and EMF gets induced. The EMF induced in the coil is given by ES minus d phi by dt minus d by dt of BA cos omega t. Or this is equal to minus BA into d by dt of cos omega t. Now E is equal to cos omega t differentiation as minus sin omega t into omega, therefore it is BA sin omega t. Now the induced EMF is a function of sin omega t. Now in this case we have taken a coil with one turn. So if the coil has n turns, then the total EMF induced will be, multiply this equation by n. If the coil has n turns, then the total EMF induced A is equal to, so this equation has to be multiplied by omega here, It's BA omega sin omega t. Just correct it. BA omega sin omega t, because cos omega t differentiation is B into A into omega sin omega t. So this will come as N BA omega into sin omega t. Now the induced EMF is NBA omega into sin omega t. Now if omega t equal to 90 degree, or when sin omega t equal to 1, then E is equal to NBA omega, and this is called as the maximum EMF induced. Maximum EMF. The induced EMF becomes maximum when sin omega t is 1, that is when omega t is 90 degree, or E is NBA omega. And this is the coil, that is omega t is 90 degree, or sin omega t is 1. This is the case when the plane of the coil is parallel to the field B. I can show you in this picture. When the plane of the coil is parallel to the magnetic field, maximum EF is induced, because when it is rotated, the flux changing, this will be maximum. The change in flux is maximum, then the EMF induced is maximum, because E is proportional to d phi by dt. When the plane of the coil is parallel to the magnetic field, maximum EMF is induced. Similarly, when the plane of the coil is perpendicular to the magnetic field, zero EMF is induced. In the coming class, I will explain about this different positions of the coil with respect to the magnetic field and how you get the sinusoidally varying EMF. Now in this session we have seen mathematically about the induced EMF calculation.